So 6.3, what we are going to study? We are going to study a theorem called central limit theorem. In short, CLT. Everybody, I think there's a typo here. It should be CLT, right? Not CLM. Okay. So what's the essential intuitive understanding for this central limit theorem? Everybody, say we have a very large class. Large class, say we have like more than, several hundred people in my class. Okay. And then I don't really know, after the exam, right? How is our class perform? I don't know every single person, their exam score. I don't know that. So in other words, I don't know, like say we have 500 people in my class. I don't really know each of them what's the exam score they have, right? But I'm able to find out. Here's the thing. Like, for example, I'm allowed to randomly ask 10 people from my class, from this class here, right? So that's what I was doing the first one, right? So if I random ask 10 people, the first sample here, and based on those 10 people, right, we find out the average score for those 10 people is 75. Okay, say for example, even though I don't know overall, right? Just for example, you say if I have 500 people in my class, I don't know all of them, right? But I'm allowed to ask 10 people each time here, the first sample, right? And then I'm allowed to repeat this. The second time, I'm allowed to randomly ask 10 people again. I mean, some of people maybe ask twice or different, doesn't matter as long as random. And the second time for those 10 people, their average is about 74. So this is the sample average here. Is that right, everybody? Is you can kind of understand this one. Each of them here is a sample average, right? And I do this, like for example, 4 times. The third time, I got the average of those 10 people is 75 again. And then the fourth time, the random sample of 10 people, I got the average of them is what? 76. Everybody? Based on those 4 samples, right? It's very small, limited information, right? I don't know what's happening for all those 500 people, for example, okay? I don't know all of them. Each single students, what's the exam score for them? I don't know that. But I'm allowed to ask like 40 people here like that, right? Each time I random choose 10 people, right? This is the average I'm getting. Now, if I tell you overall for our class, at the end, the average is 75, would you be surprised? No, right? Because from those sample here, like the first one, 75, second one, 74, third one, 75 again, third one, fourth one, 76, right? So they are around like this number 75. So if I tell you at the end, right, our class average overall is about 75, I wouldn't say it's a big surprise, right? So this central limit theorem, what's that trying to tell us is try to tell us the distribution of this sample average. Everybody, the distribution for this sample average, it turns out they follow a normal distribution. Okay, they follow a normal distribution. So we are going to use some notation. I'm going to introduce some notation here. Let me erase some stuff here. I don't need that. Okay, so yeah.
Pardon me. So if this example is a normal distribution sample, I presume that we're going to follow the same formula steps to get the final answer. So am I understanding that to point out that it is a normal distribution sample, the very moment we read it, do we get to identify it as a normal distribution based on the word average in the sentence? It says the word average. Calculate average math score.
If I'm understanding your question correctly, are you asking, number one, the sample average here, this X bar, they follow a normal distribution. So this one here we mentioned previously, we know as long as we have decent sample size, this sample average, right, is always, follow a normal distribution. That's the one we are trying to do here. We know this sample average, they follow a normal distribution. And we know exactly what's the average will be, what's the standard deviation will be. Is that your question?
I was actually referring to the original question where it says part 1 example, randomly sample 10 students, calculate average math score.
Okay.
That part.
Okay.
So I was wondering if whenever we see the keyword average in that sentence, that should be a symbolism telling us, oh, this is a normal distribution equation.
Yeah. If that helps you to remember, yeah, you can use that average to remind you, yeah, they are talking about normal distribution.
Okay.
Yeah, that's a good one. Yeah. So this sample average here turns out that follow a normal distribution. And what's the average here? The average is for example, we call this true average. The true average, usually we are using the notation mu for that, right? So in other words, the sample average, right, they should be distributed around this true average. Sometimes might be a little bit bigger, sometimes might be a little bit smaller, right? But most of the time should be around this number of mu. That's the key idea, right? And the variance here is following this sigma square divided by m. So where is the sigma square? Sigma square is the variance for the single case, right? The single sample case here. And for this one here, we have a sample average. So we have to divide by, because when we have a sample, right? So that comes as the sample size of m. So we have to sigma square divided by m. In other words, for this 6.3 here, we will use, you probably see some formula that is similar to this one here. Previously, we have a Z formula. If you remember, what's the previous Z formula we have used, right? Z formula x minus mu divided by sigma. That's the previous formula we are using. Everybody? The Z score, right? Now the question here is, this X here is what? Is the one single case. Usually they're asking, for example, I randomly select one sample. What's the probability of that one sample less than 1 cup of coffee per day, like that, right? That's the X we're using. We're talking about one person, one subject. In this Z formula here, right, we don't talk about one person, one subject. So we talk about multiple subjects, a sample here. So this will be the new formula we are going to use. So what does that mean? That means we are going to use this new Z formula to help us find out all kinds of probability questions. Okay, so bear with me. I think right now it's still a little bit of theory, right? Theory stuff. It's not that straightforward, right? Let's use some example here to help us understand how do we apply this Z formula here. And this Z formula here is coming from central limit theorem. It's study the sample average. Whenever you see the sample average, right, remind you this Z formula here. Okay, so example number 1 here, we are given the information that about those children, right? On average, they watch how many hours of TV per week? 25 hours of TV per week. That's quite a lot, right? That's not healthy, right? 25 hours of TV per week, that's more than 3 hours a day, right? No good. So the standard deviation is about 3 hours. That's sigma equal to 3. Everybody? When they are given those information for you, right? So that means what? That means each child, right? They how many hours of TV, right? Every week, right? So they follow a normal distribution, right? Average is always the center, about like 25, sometimes higher, sometimes lower, right? And by the central limit theorem, we know if we randomly select a sample, you see, more than one sample, everybody, that's the tricky part. So starting from 6.3, we always have a sample. In other words, we always have like more than one subjects in our study, right? So now we randomly select 20 children. We want to find out what's the probability of the average TV hours for those children, okay? Greater or equal than 26.3 hours. Everybody, be very careful here, okay? Try to understand what's the question here, right? So we are trying to find out the probability of the average TV hours for those 20 children, greater or equal than 26.3 hours. Everybody remember, how do we solve that? Let's draw the bell-shaped form, remember, right? We know that they follow a normal distribution. Where's the center, right? Center is about the average 25, right? Standard deviation is about 3, right? And then we want to translate it into standard normal distribution curve. For example, that's the one we are trying to study for. Bear with me, I didn't draw a good picture here, right? So now we are using the Z formula, which is coming from this one here, right? So this is the Z formula we can apply here. Now, the question is, how do we plug into this formula, right? So here's our X. And to be more specific, here's the X we consider a sample average. So it should be X bar here, right? So the Z transformation using this formula here, right? We want to find out the probability of the average TV hours is greater or equal than 26.3. For example, if here is 26.3, what do you do next? Like this is the probability you're looking for, right? They're asking probability of more than 26.3 hours, right? So that means we do the conversion here. Okay, center to center, we got 0 or 8, no worries. And then 26.3, the question is this number should match to some number here, right? So in other words, we try to find out this probability here. If we can do that, we are good.
So 1 minus the probability?
That's right. If we find out the Z here, that's right, yeah. So let's do that step by step, right? So first, let's find out, how do we find out Z? Is Z here, right? Plug into this Z formula, everybody. Now we have a new Z formula. Why? Because we're not talking about one sample. We're talking about sample average, right? We have to divide by square root of n. So we have X bar here, which is the one we are looking for, 26.3, greater or equal than 25, right? Greater or equal than 25. Divided by sigma over square root of n. So square root of n is what's the sample size, right? Is that 3 or is that the other, right? So in this case here, we got 1.94 from the Z transformation, right? So here is 1.94, for example. Once you find out that here is 1.94, what do you do next? Remember, once you find out here is 1.94, what do you do next? We are looking for the Z chart, right? Try to find out what's the corresponding Z. So if you check the 1.94, let's see. 1.94, where is that? We have 1.9 and 1.94 is 9738. Follow me? Right, 9738, okay? So now we can write down that, okay. .94 corresponding 9738, okay. Okay, now we find out this is 1.94, right? 1.94, what do you do next, right? try to find out the probability is to the right. Is right to the right, everybody. So the probability to the right. So I was drawing that I shouldn't, right? So probability to the right of 1.94. So here is 1.94 here. So it's greater or equal to, so that means it's this area. Everybody, how do we find out the probability of this area? So we are going from the chart, right? 1 minus the probability here. 1 minus the probability we got here is what? 1.94. So that gives us the overall area here, 0.94. The other probability is 2.62%. It's very small here. This is the probability we are looking for. This second example here, we are given this information. On average, the age of vehicles in the US is about 8 years. So if we convert that to the number of months, it's about 96 months. Also, we are given the standard deviation, sigma, is equal to 16 months. So based on that information, we are saying the age of the vehicles in US, right, they follow a normal distribution. Right, so that's the information based on that usually implied. Average 96 months, standard deviation 16 months. So now we randomly select 36 vehicles. So we are trying to find out the probability of their average age, everybody, their average age. Probability of their average age is between 90 and 100 months. So how do we solve this question here, right? Everybody, normal distribution, it is a bell-shaped curve, right? Center at 96, we can draw that here, right? And then, let's see. So center about 96 here. And we are asking, find out the probability of those average age, right? Average age between 90, say here's 90, to 100. And where's 100? 100, say somewhere here, right? 100. Okay, so we are asking the probability in the middle, everybody. Is that right? Probability in the middle between 90 and 100, everybody? So that is what we call this X, right? This is X. And in this case here, this X is what? Is our X sample average. Everybody? It's out of 36 vehicles, okay? So the central limit theorem, everybody, if you something try to help you remember, is what? The difference for this section here compared with the one we just learned, right? This section here is using sample average. If you remember the 6.2, we don't have X bar here, right? We just have X, if you remember that. So you can consider this is as the case. You have more than one sample, right? Previously, we only have one objects, right? Okay, so once we understand the question, right, we convert to the standard normal distribution curve, right? So now we can draw this standard normal distribution curve. I'm trying my best here. So the center would be 0, right? Remember, okay? And then we're trying to see what do you call this? 90 will probably map to some number. 90 will probably map to some number, say somewhere here, right? 100 will probably map to some number here, okay? So you will have like Z1 here. You will have Z2 here, everybody. You see, that is very similar to the one that we just learned, is that right? So in other words, we try to convert, right, previously we have x1, I mean, is x bar 1, right? So you see that formula here, we have x bar, that's the difference. Previously, we just have like x, right, x bar. Because we have x bar, because we have a sample, then you have to divide it by the sample size, n here, okay? So some tip to help you understand, like we have two formula, pretty much two formula. This is one formula we learned tonight, right? Compared with the previous one we learned. We have two Z formula. The questions on the homework, on the exam, which formula you have to use, right? So what are those keywords to help you remind you, right? Oh, should I use this formula or should I use the other one? Okay, so here's the tricky part. To use this formula here, to use this Z formula in terms of a sample size, right? Always you will have some information, say, randomly select a sample. Okay, that's question number one. Always you will have a random sample, okay? The hint, number one. Number two, they will always ask you, what's happening to this sample average? Like this case here, they're asking the probability of their average age, right? So they're asking something about this average age of those vehicles, right? So in that, given those two information, you decide you are using this formula, not the previous one, right? This case here, you have a sample size, n here, right? Like for the previous one, when we have like pretty much that formula here, we don't have a sample size here. I hope that is clear. Now, how do we find out Z1, Z2, right? We plug this number into the formula, everybody. So X bar is minus mu divided by sigma over square root of n, right? So write down step by step. Mu is 96, we got that. Sigma 16 divided by square root of 36, sample size, right? So what's this number here corresponding to? That's the sample average, the first number we are trying to map, 90, right? So we plug that, we got here, Z1 is equal to what? Negative 2.25, everybody? It should be negative, is that right? If you consider that it's to the left of 0. Follow me, right? To the left of that 2.25. Similarly, we can plug the 100 here to find that Z2 is equal to 1.5, right? Follow me, everybody? So this 6.3, in a way, that is easy because you can understand that way. We simply switch one formula, right? Everything else is actually almost the same. We just use a different formula to do the calculation, if that helps you understand the difference. Okay, for this 6.3 and 6.2, you are using a different formula. The other stuff are very similar. So we are trying to find out the probability in the middle. Is that right? You see, that's the one we learned already. How do we find out once you know Z1, Z2, right? So you are using the table directly, 1.5 give you the probability to the left. That's everything to the left, right? Find out from that table, minus this piece here, that probability, right? That'll give you the probability in the middle should be what? 92.1%. Because here's 92.1%, that also tells us the probability in the beginning when we ask, right, is also 92.1%. I hope that's clear, everybody. So that's the way to solve this probability question. It's very, very similar to the one we learned. Any questions before we go to the second example? We are trying to cover each case here, right? We have it to the left, to the right, in the center, right? So previous example number one is for the, to the left. Now this one is in the middle. I'm trying to see the next one here might be to the right, right? Let's check that, okay? Now, let me erase those the notation here, all right. Now, the second example here, the third example here, on average, we are given a person, right, consume 218.4 pounds of meat per year. Standard deviation, 25 pounds. Everybody type in the message window, if you eat on average, if you eat more than 218.4 meat per year, tap yes. Otherwise, tap no. Okay. Meat could be chicken, could be any pork, right? Anything. But like you think, so 218 divided by 365, that's about 0.6 pounds per day, like that. Okay. I'm just trying to understand. So if you, on average, every day, if you eat more than 0.6 or 0.7 pounds per meat, that means, I mean, you eat more meat, right, than the average. Okay, so those are the information we are given. Now, question number 1. You see that previously we mentioned there are 2 hints, right, we can use to help us decide which formula to use, right? So hints number 1, we randomly select 40 people. You see that? So that is given some random sample data set. Okay, so that's the question, the number 1 condition, you can consider that way, right? Given this condition, okay. Number 2, they should ask, in terms of the average of those 40 people, then we should use that formula if they're asking that way. So in other words, they should ask the average 40 people, I mean, for those 40 people, their average consumption of meat per year, right? So the question here is find out the probability of their average. Everybody, they do ask that average, right? So they're asking the probability of their average consumption of meat, right? Everybody, less than or equal to 224 pounds of meat per year. So what do we do here? We try to draw the bell-shaped curve here, right? You see, for the homework, for the exam, always draw the bell-shaped curve, right? Average here is what? 218.4. Now we're asking the probability of those average consumption of meat less than or equal to 224. 224. So in other words, we're asking the probability what? To the left. Is that right? Follow me? Everybody, probability to the left. That's the highlight area. That's the one we are trying to solve. Remember, right? Now, so we always do the conversions, right? So in other words, we always try to draw another bell-shaped form, remember, right? Always do that, so you don't get lost. The center should be 0 because standard, right? So we're trying to see this 224 should be mapping maybe some point here, right? Say Z, right? So how do we find out Z? I mean, using that formula we are given here, right? So it turns out this Z should be what? 1.42, right? 1.42, that's the probability we are trying to find out here. 1.42, right? 1.42. Okay, so in that case, once we find out 1.42, we are asking probability to the left. That is very straightforward, right? So you're simply looking from the Z table. The probability here is 92.2%, everybody. So that 92.2% should be the same as this part here too, right? 92.2%. Follow me? Okay, so that's everything to the left. Now, question number 2. Question number 2 is very similar. They only change one thing here, okay? They only change one thing. What's the change here? They were saying, find out the probability of randomly select one person. Everybody check that, right? Randomly select one person. Compare with the previous one, you randomly select 40 people, you see? So in that case, you can consider this question 2 is what? Is the sample size now n is equal to 1, everybody, right? So in other words, I mean, if you still want to use this formula, that's totally fine, right? In that case, a sample of 1, so actually just that person itself, right? So in that case, we divide by square root of n is square root of 1, which is still 1, right? So we apply the same formula, everybody, right? We find out the z-score is what? 0.22. So previously, if you remember, the average of 40 people, we find out the z-score is 1.42, right? Now, after we switch to the 1%, right? We find out the probability is what? 22%, everybody? Which is less than what we have in the earlier, right? 92.2%. Is that clear? So that's the way help us understand when we have to use the new formula or when we have to use the old formula. Okay, so we've calculate. You see that one probability 92.2% when you have the average of 92.2%, right? Now you have only one people here, right? One person here, right? That's a major difference. Okay. The answer is different, everybody. One is 92.2%, the other one is 58.7%. You see, the first one is bigger than the second one.
Yes, sir.
Yeah.
I have a question. I'm a bit confused between the 40 people versus one person.
Yeah.
Doesn't that the z-score formula for finding one person change? Doesn't it change the formula? Back to the original.
Formula is the same. So you see that formula here? You see that formula here? It's the same ones, right?
Mm-hmm.
Now, you see what's the difference for this one and that one?
Well, the first one is a sample and has many people, 40 people.
That's right. You see, that's the actual only difference. Here you have sample size n is equal to what? 40. You see that here?
Mm-hmm.
Sample size here, n is equal to 40. So you plug n is equal to 40 here. What's the sample size n here in this case, second case?
It's only one person, but I was just wondering, don't we go back to the original formula for the z? Because it's only one quantity, one
That's
person?
right. So the original formula is you can understand the original formula is the same as this one when n is equal to 1. Is that clear?
When n is equal to 1.
Yeah.
Oh.
So in other words, if n is equal to 1, those two formulas are the same.
Oh, so you could still apply it anyways.
Yeah, you can, if n is equal to 1, you can use either formula.
Mm-hmm. You put an invincible 1. And what about the x average?
So average of one person.
Oh, okay, so we're not really adding anything. It's not like a...
That's right. Like average of one person, just the person in itself, is that right?
Mm-hmm, mm-hmm.
Yeah, so that's the reason when n sample size equal to 1, this z formula is the same as the other one. So that in that case, it doesn't matter which one you are using.
Okay, that makes sense.
Okay, so only when you have more than one people, then you have to use this z formula here, involving the sample here. Okay.
All right, thank you. I appreciate it. That makes a lot of sense.
That's a good question. Yeah. All right. Let's continue our